Hello, and welcome back. In the previous lecture, we have integrated Redis into our application. In this lecture, we'll learn how we link the Redis container and our Python app container, which will allow them to talk to each other without having to expose any network ports. This can be done using Docker container links. Container links allow containers to discover each other and securely transfer information about one container to another container. When you set up a link, you create a conduit between a source container and a recipient container. The recipient container can then access select data about the source container. In our case, the Redis container is the source container, and our app container is the recipient container. The links are established by using container names. Let's see this in action. First, let's run the Redis image in a container and give it a name Redis, which will be used to establish the container link. Here, we use the latest Redis image, which is 3.2.0. Now, Docker is downloading the Redis image. After the download is complete, we run docker ps to verify the Redis container is up running and is named Redis. Then, in the second step, we build our Python app image and tag it with v0.3. The build completes successfully. Now, it's time to run our Python application container, which is the recipient container. This time, we start the application container in almost the same way as we did before, except we add the double dash link option and specify link to the Redis container so that the app container can connect to the Redis container using the container name Redis. Do you remember in our app.py file, we have used the Redis container name as the host name? This is where the Docker container link's being used. Now we just hit enter to start up the container. The container starts immediately. Let's switch to browser and refresh the web page. See? The application is up running. Here we do some basic key value lookup to verify the app is functioning as expected. Great! Everything worked well. So far, we have demoed how to use Docker container links to get our app container working together with a Redis container. You might want to ask how container links work behind the scenes. I'll show you in a second. Let's log into the Python app container first. What I'll do is that I'll open the etc hosts file. When a Linux machine gets started, it will need to know the mapping of some host names of the IP addresses before DNS can be referenced. This mapping is kept in the etc host file. What you see there is an entry created for our Redis container. Here is the Redis container name and the container ID. So host name Redis will be resolved as the IP address on the left column. The IP is the IP address of the Redis container. Let's approve that. Just run docker inspect Redis container ID to inspect our Redis container. And grep IP. You see? The Redis container IP is 172.17.0.2. We can also verify that by pinging Redis inside the app container. Let's log on into the app container again and ping Redis. You see? It is directing the echo request to 172.17.0.2. Let's summarize here. The main use for Docker container links is when we build an application with a microservice architecture. We're able to run many independent components in different containers. Docker creates a secure tunnel between the containers that doesn't need to expose any ports externally on the container. You'll note when we started the Redis container, we did not use -p flag. That's a big benefit of linking. We don't need to expose the source container, here the Redis container, to the external network. That's it for this lecture. I'll see you later.